Hey guys, welcome back to my channel Code Canvas. There is one mystery feature of JavaScript functions that many developers fail to fully understand. And what I am talking about is closure. I believe with the right explanation, it's actually not that hard, especially when you understand execution context and call stack. Because closure is the combination of all these concepts in a beautiful way. So, enough talk now. Let's see what closures are all about. The first thing you need to understand here, the closure is not a feature that we explicitly use. We don't create closures manually like we create new arrays or new functions in JavaScript. So, a closure simply happens automatically in specific situations. We just need to recognize those situations that what we will do in these examples. Okay, so we will create one of these situations so that we can take a look at closures in action. So let's open a code. Let's create one function. The function name we can give anything. I'm giving a name is booking. Okay, and I'm using ES6. Booking function is equal to, I'm declaring one variable student count and initializing that value to 0. Okay, in this booking function, I'm returning another function, a child function, inner function, and in that function, we will increase the value of student count variable by 1. Okay, and let's add one console saying that the student count student. Okay, so we have created one function, and with that function one variable assigned value 0, initialized value as 0, and this function is returning another function that has the same value which is increased by 1 and adding some console that will print this variable value. Okay, so let's call this function. Let's give the value to that function name is booker, and let's call this booking function. So what this booker variable consists of? This booker variable is a function that will return this function. So the booking function is created with one variable and one function, and booker variable is having a function. Okay, so let's see. Let's call a booker function because this booking function is returning another function, this inner function, and to call this we have to call a booker function. Okay, so let's save and see what it returns. So one student, because the student count is increased by 1. Okay, so how this function is working? So if you know the execution scope and execution context, okay, so this booking function is created in global scope, and this function is created within booking function. So when you create a constant named booker, it will call this booking function in the global context because booker is in global context, right? So booking function will return and it will store in booker, and when you call the booker, it will call this inner function. So if I call this booker function 4 times, let's say, yes, what will be the student count? And let's see, it is incremented by 1 every time we call. So how it is possible? Because when you create a booker variable, the booking function is called, and from the stack, once this function is called, it is removed from the stack. So how this Booker function have access to student count variable? When the Booker function is called, the Booker variable is created. This function is already executed. That is not in stack, right? Then how this Booker function has the access to student count? That's what closure. So the Booker function continues to have the access to the variables that were present at the time the function was created. So the function was created here, and the creation of the function, at the time of the creation of the function, the student count was created. So Booker function continues to have access to the variables. So Booker function has access to this variable where present at the time the function were created. Here student count variable, so that's exactly what the closure does. What we can say here, that a closure makes a function remember all the variables that existed at the function birthplace. So what closure exactly does? Closure makes a function remember all the variables that existed at the time of function's birthplace. So the function's birthplace is here. The Booker's function birthplace is here. So closure remember this variable no matter that booking function is on the stack or not. So this is closure. Maybe it's little bit confusing at this time, but we will see another example. We will have another two examples. So any function always has access to the variable environment of the execution context in which the function was created. Okay, let me repeat again. Any function always has access to the variable environment of the execution context in which the function was created, even after that execution context has gone. The closure has priority over the scope chain. So the closure is always having a priority over the scope chain. I will show you later what exactly the scope chain I'm talking about. Okay, so let me repeat the definitions of closure. Function bundled with its lexical environment is known as closure. So this is a little bit confusing, but it is also a valid definition. In simple terms, you can say a closure gives a function access to all the variables of its parent function. So the function in which it is defined even after that parent function has returned. So the function keeps a reference to all its outer scope even after that outer scope is gone, which basically preserves the scope chain throughout the time. So this is what variable I am talking about. The third definition, in a simplest way, you can say a closure makes sure that a function does never lose a connection to the variables that existed at the function's birthplace. It remembers the variable even after the birthplace is gone. So this is a simplest definition. Okay, let's see with another example. Let me simply comment it out. Example number 2. Okay, let's create one function x is equal to function, and I have one constant a, the value let's say is 40. Okay, before that I am declaring one variable, and I am assigning that variable a value of function. So here you need to consider one thing. It is not always necessary that closure is about to return a function. Okay, I will show you in detail. So I'm creating one function. I'm reassigning a value to f and creating one function, and in that function I'm adding one console saying no need for template, we can simply give a into 3. Okay, and that's all. So this is function x. Okay, We will create another function y. Okay, in function y I am creating another constant, say b is equal to 99. I'm again creating same function, assigning same f and console.log a into 3. Not a, we will have a b, the b variable. Okay, so here I am creating two variables, two functions. Okay, now I am calling first function x, that will call this x function. It will create a stack and execution context. In this execution context, we will have variable a is equal to 40 and function f. So guess what will be the value. So after x, we will need to call f. Once you call f, you will see the output and it will be 120. So 40 into 3, it will be 120. So this is expected, nothing is wrong. So here you can use console dot one function is there, dir and f, the function f. So let's see what it returns. It returns these values, and here as you can see scopes. In scope, in you can see a closure. The closure is created for x function. Okay, closure is created for x function, and in that function the a is 40, which is correct. While we are calling this function outside here, still this function has access to its outer function variables. That's what the closure is. So as you can see here in scopes, closure value of a is equal to 40 and the closure is created around x. Okay, so this is expected. After that, I am calling function y and again calling function f, and let me comment it out so we can see. Okay, so 297, and what will be the value of b? 99 into 3, which is 297. That is correct. Okay, so this is fine. And again, if I am using console.dir and function f, let's see here the scopes, and in scope you can see closure is now created for y and the value of b is equal to 99. So let me just uncomment this and see what it returns. So this is 120, this is fine. For this, it is scope is created around x and the a value is 40. And for this second f function, the scope is created, the closure is created around y and the b is 99. So this function is called from this y function, and that's why the closure is created around this y. Okay, so as you can see, the function f in this y function has access to b, which is in outer context, but it is still having the the access of this b variable. So this is also a very good example of closure. Okay, let me comment it out. Let's add example 3. I'm creating this function for students for exams. Okay, so in I'm creating one function called exam, and in exam I have number of students, and I will use set timeout, and for that I will use one variable which is wait time. Okay, waiting, so it will be a waiting value. So here I am creating one construct, that group will be number of students by 3. So students are divided in groups, and 3 groups divided by 3. Okay, so this is group. Okay, I am creating one console.log and I'm using will start exam in here. You can give waiting is a variable and seconds. So wait time will be a set timeout waiting. I will show you how it works. Okay, here I am adding set timeout, and timeout will be a waiting variable into 1000. So this will be milliseconds and into 1000 will be seconds. So waiting variable. Okay, and in set timeout I will again use one console, and in console I will write down some text. We are now starting exam for all year and number of students. And again I will add another console log, and we will write down some text saying there are three groups of students. Okay, each each group with, here we need to use group variable students. Okay, and this is waiting of dollar. So this is a waiting. So let's call this function. Let's say we have 120 students and we need to wait for 5 seconds. So what this function will do, first of all, when this function is executed, it will wait for this number of seconds, 5 seconds, 5 millisecond into 1000, it will be 5 seconds. Before calling this set timeout, it will simply console this text because it is outside of this set timeout. It will not wait for set timeout. So it will console this message, and after 5 seconds it will console we are now starting exam for this number of students and this as well. So let's see. Let me reload, and after 5 seconds it will return text. So we'll start exam in 5 seconds. This is the text which printed, and we are now starting exam for all 120 students. So 120 students, and we are now waiting for all 120 students. After that, there are three groups of students, each group with 40 students. So group will be 120 by 3, which is 40. So this is working fine. So as you can see, it will wait for 5 seconds and then two messages will be printed. So if you are curious how this is working, the group variable is here within this function, right? Then how this set timeout is able to access this group? That's what closure is all about. Set timeout function is waiting for few seconds, here for 5 seconds, but still this group variable is accessible within this set timeout function. So this set timeout function is having access of this group variable. When this exam function is called, the execution context is global. The exam is there, but exam function has no access to group because the function is already been called, but set timeout is having access of this group variable because of closure. So this is what all closure about. One more thing, when I said that closure is taking priority over other context, as you can see, so how it is possible. So here let me create a group variable again, and I am giving value to 400. Okay, so we already have group here, but I am creating that group in the global scope. Okay, So the closure has priority over the scope chain. How? So let me just save and see. As you can see here, this is fine. And after 5 seconds, now we are starting exam for all 120 students, which is fine. And there are three groups of students, each of having 400 students. So this is 400. But if I am removing this and just again, then it will take this value. As you can see, it is 40. So that's what I'm talking about. The closure has priority over the scope chain. So this is an example. Okay. I hope you learn something new, and the closure is very complex and not complex but little bit complicated subject. So hope I try to explain this in a better way. If you have any question or if you have any comments, please leave your comments. If you like this video, please subscribe to my channel, and I'm going to create more videos of JavaScript and advanced JavaScript as well. Thanks for your time.